Okay. So yesterday I explained about the synthetic profile. So synthetic profiles are basically called load profiles. The synthetic profiles are used in those situations where we do not have the actual smart meter, but using a actual smart meter, we can generate the data for a sample installation, like a two-bedroom apartment or a three-bedroom apartment or a commercial installation with certain load which is installed. And based on that, we actually collect the data for a particular sample day, like a summer weekday, summer weekend, or winter weekday, winter weekend. These are called basically day profiles because the profiles will contain the data exactly for one day. And then we create synthetic profile, connect the day profiles with the synthetic profile. And then based on the data what we have in the day profiles, the data will be generated for the synthetic profile. Now, whenever synthetic profiles are generated with the data, system will also create one more profile in the background, which is called integral profile. So synthetic profile is what we create and then generate the data in the background. There will be a profile created also with the value in the background by SAP, and that is called integral profile. Now, what is the purpose of integral profile? We will see. First, in order to create synthetic profile, we have to maintain the season group and the day group. So we will go to EDM, select utilities, go to EDM, and then basic settings, season group. Now, season group means basically just like we have the time of usage group. In time of usage group, we had a group containing one or many time of usage type. Likewise here, a season group will contain one or many seasons, and each season type will have the months for which the season will happen. So that means the summer season happens in which months, winter season happens in which month. Whenever you put this season type into a group, you should account for 1 year, 12 months. So we will go to define the season type. We can make use of some existing season type which is already available here for our testing purpose. 0001 is called as summer here, and then definition, it is starting from 1st of April to 30th of October, 30th of September. During this period, whatever consumption happens, we are going to take it as consumption in the summer. So 1st of April to 30th of October. Now 30th of September. Now the consumption happening from 1st of October to December is going to be winter, but winter will happen actually in 2 years. In the current year, it will happen from 1st of October to 31st of December, and next year it will happen with January to then 31st of March. Just like off-peak usage type is split into two parts, up to midnight because it happens on one particular day, and then it's going to start again from midnight to next day morning. Okay. So likewise here we have got what we call. So here likewise we have got what you call the season splits into 2 years, partly in 1 year, partly into second year. So if you go to the winter definition, it is starting from 1st of October to 31st of December, and then again from January to 31st of March. We do not say it is starting from 1st of October to straight away 31st of March. It will not have one single line, it will have two lines because the year also will come into the picture. That's the reason it is split into two parts. These season types are put into the season group. So if you go to define the season group, 0001 season group, year divided into summer and winter. So now we will go to definition. It is having two season types, 0001 and 0002. Now, there can be more than one season type or more than two season types also. We can create those and then put them here. So basically season group contains all the season types, and all the season types put together should account for 12 months. That's the whole idea of the season group. Now within the season, we are going to have the day. Okay, so we come to now day group. That means we are going to distinguish between the two types of day. Now, weekday and weekend. Usually weekday weekend concept will come from the factory calendar. In the factory calendar, we will have what are the weekends, like is Saturday, Sunday weekend, or only Sunday is a weekend, Saturday is working, or the public holidays. The public holidays are also considered as kind of holidays. Weekends are considered as kind of holidays. So public holiday weekend will remain the same. Okay. So here we have got defined day types. There are two day types here. 0001 is weekday. How will the system know weekday? Because you are assigning with the factory calendar 01 and marking it as working day. So working day is basically as available in the calendar except the weekends and the public holiday. Likewise, we have got the 0002 that is supposed to be weekend, marked as weekend, and then weekend and public holiday being the same. Public holiday is ticked here, which means it is also along with the weekends. So two types of days we are considering, because usually we see a pattern of consumption varying between weekday and weekends. That's the reason we are splitting the days into two types of days. But again, it left to the company. If they consider all the days are same only, then you can have only one day. That is, all the days are same. Okay. So these day types are put into day group. Define the day groups. In 0001, weekdays and weekend days, we have defined two types of day types, that is 0001 and 0002. Okay. So essentially we have created a season group, or we have the season group and the day group. Now how to use it in the creation of synthetic profile, we will see. Now first what we have to do, we have to create 4 day profiles. Summer weekday, summer weekend, winter weekday, winter weekend, then fill up the value. Then we have to create synthetic profile and assign these day profiles to the synthetic profile. Also, we have to create one more type of profile, which is called dynamic modification factors. So this dynamic modification factors will have the factors which are calculated for the variations, what will happen throughout the year. Okay, that means the values we cannot enter, the values will be generated by the system using a module program. For the residential consumer, SAP has given one module program. Using that, we will generate the data for the dynamic modification factor value profile. This also will be entered in the synthetic profile. Based on this, the system will generate the data for the particular year, what we require. Let's say this year, next year, and maybe, I mean, you can create as many years as you want. And then the profile what you create will be assigned to the installation. Okay. So first we'll go to the device, the EDM, and then go to profile management, profile header, create. Here we will take it as summer weekday. Division is 60. Profile type we have to select as day profile. Select as day profile. Consistency check group. We will say it is valid from 01/01 2019. Interval length we are going to select it as 15 minutes. It's going to contain the energy value, so we will say quantity, which means it is going to be kWh, decimal value to cumulative value. So we are generating the first profile, header data, summer weekday, starting from 1st of January 2019, 15 minutes interval, profile value category, quantity, KWH, 2, and then save it. So the profile created for the summer weekday, that is 149. So profile number 149. Then we'll save it and then create the new profile. Summer weekday, weekend. It's again day profile. "15 minutes, KWH, quantity, decimal places 2, and cumulative values." So the second profile we are creating it as summer weekend, day profile, 1st of January 2019, 15 minutes, KWH, quantity, decimal places 2, and cumulative value, and then save it. So profile number 150 has been created. Now let me check once 149. The day profile. Okay. Now I'm going to create winter weekday, day profile 0101, 15 minutes, KWH, quantity 2, and then set. So 151 has been created. Now we'll create the last profile, that is winter weekend. Cumulative values. So basically 1st of January, 15 minutes, quantity, KWH, and then it is for division 60, and it's going to be winter weekend. Save it. So this will be 152. Okay. So you have created 4 profiles, 2 for summer, 2 for the winter. Now we'll create the next profile, which is called the dynamic modification factor profile. So create dynamic modification factor. It will be considered as basically a historical profile. Basically, it's going to contain the values with historical date. So it is not day profile, it's a historical profile. Consistency check group, valid from 0101 2019. Interval length is going to be 15 minutes. The profile value category will be factor. Okay. Now factor is basically, it's a number. It's not having any dimension. So it is not concerned with the mid-reading unit. So nothing you have to fill up here for the measurement. It's just going to contain the values which are calculated by the system. And here we must maintain at least 2 decimal places minimum. Okay. Because if you don't maintain any decimal places, then all the values will become 1. Okay. But it won't be like that. For some period it may be 0.9, some period it may be 0.8, 1.2, 1.1, because system is going to calculate the values for multiplication with the actual values. So we have to ensure minimum 2 decimal places are maintained, and then no need of any cumulative value. So it's a historical profile, 1st of January, and then duration we are taking 15 minutes. Profile value category is factor, no measurement, and then decimal places too, and then save it. So profile number 153 has been created. Okay. Now this is the profile for the factors, you can say. Now first let us generate the data for the 153 profile, that is basically the dynamic modification factor profile. So we will go to synthetic profiles, generate the dynamic modification factors, and our profile number here is 153. So enter 153. This is the function module program, VDEW. This is for the residential consumers. If required, the ABAPer can create the new module program for the commercial consumers. And then year is going to be 2019. Select 2019 and then generate. As many years as we want to create this entity profile, for all those years, the dynamic modification factor value should be available. So we'll start with the 2019, execute, and then we will generate for 2020. Let us say we're also creating for 2021 and then generate. Now we can have a look at the values what it has generated. Go to profile values in display mode, and our profile is here 153. Let us take it for 1 year, 0101 2019 till 31st of December 2019. Select it here. So here you can see it has generated the value 1.24, 1.24. But when you take particular period, let's say for example, if you go to, it is starting from 1st of January. Now if we took to March, for example, one of the day 22, it is becoming 1.10. So it is starting with 1.24, comes to 1 and then goes down till when the winter will come. So these values will be multiplying with the actual day profile to do the correction for the smooth generation of profile where it is going to cross the seasons. Okay, so we don't have to fill up the value will be generated automatically, and you can see minimum 2 decimal places we have to maintain, because if you maintain no decimal places, all the values will become 1. So now these values are generated. Now we'll go to create our synthetic profile. So we will say this is going to be synthetic profile for a 2-bedroom apartment. File type is going to be synthetic profile, consistency check group, valid from 0101 2019. It's going to contain interval length, that is 15 minutes, profile value category, quantity, KWH, decimal places to cumulative values. So I'm creating now the last profile, which is basically synthetic profile. And then status check group is maintained, 1st of January 2019, interval length 15 minutes, KWH, quantity, and then 2, and then decimal places, and then save it. So we have generated 154 as the synthetic profile. Now to this 154 synthetic profile, we have to assign the 4-day profiles, and then we have to assign also dynamic modification factor profile values. So first we will go to details. Here you can see details. Enter the season group. The season group is 0001. Year divided into summer and winter. Day group, we are going to have weekdays and weekends. And then allocation category, day profile, values not normed. Values not normed means if you don't norm the values, then you can create for any number of days or months or any number of months or year. For example, I can go on generating the sensory profile value for first month, second month, third month, or at a time for 6 months, at a time for 12 months. Okay. But if you norm it, then you have to generate for exactly same number of months. That means 1 year. Okay. And that means at a time you have to generate for 1 year minimum, or 6 months, or 2 years. So norm means it is fixing the period for which you are going to generate. But if the values are not normed, then you are free to generate the value depending on your months what you require. So generate or display profile value, we will say from 01/01 2019 till 31st 12 2000, 31st 12 999. Enter. Now here we will see there are, according to season group, there are summer and then the winter. Okay, so here you can see summer and winter. Now select the summer weekday and then select the weekday. Okay, so in the weekday we have to assign the profile what we have created. So select here, create the allocation, and it is starting from basically 1st of January 2019 to 31st of 999, and summer weekday profile is 149. Enter. Select an active profile. Okay, so it is better we will not create it. First we will fill up the data and then add it. Save before. No. Okay, now we have created the values, so we will put the values into the profile. Now what are the values we are going to select? Let's see. Now here we have got two profiles. Let us say I call it as 149 and 150, 151 and 152. So we'll generate some data. Let's say this is for summer weekday, summer weekend. So here I will take it as here I will select it as winter consumption can be more or less depending on the country. In some countries they may use heaters and all, it may be more, or in summer you use air conditioner. So it can depend on the actual value, but here I'm taking less than the summer weekday. So I will take it as C3 into 0.03 into 0.8. Now these two will maintain the format. Number, decimal places to select it. So you have generated some data here, test data. Now we will also create for the last profile. These are the values we have created. Now let's select this data, copy. And then we will open the profile number 149. Now while entering the data, we must enter it for 1 day. I mean, the day has to be same for all the profiles. I mean, it doesn't mean that summer means happening in March. So you're entering one date in March, or it is happening in winter, one particular day in winter. Although months are segregated, while adding the data, it is considered as one sample data for a day. So all the profiles should have the value for the same day. Then only you'll be able to generate the data. So we will take one particular date as 01/01/2019, and it is for one day only. So 01/01/2019. That means starting from midnight to 11:45. That's the duration for which we are going to enter the data. It cannot hold the data more than 1 day because it is a day profile. Select it and then paste and then save it. Now we will go to 150, the profile. Same period of duration, and then we will select this particular data. Now we will select 151. And then we will create for 152. So we got all the profiles. So 152, then 149, and 153. For all this, we have generated the data. So all the 4 profiles, we have got the data generated, and then save it. Now we'll go to create the synthetic profile. Synthetic profile type is synthetic, consistency check group, interval length is going to be 15 minutes, file value category, quantity, KWH, decimal places to cumulative. 1st of January, 15 minutes, quantity to measurement, KWH, decimal places to, and it is basically synthetic profile, category 60, division. Go to details, save before, first save it, then go to details. So season group is going to be 0001 and day group is going to be 0001. And here, even if you don't enter the date, it is okay. While generating, you have to enter. But you will enter 01/01/2019 up to 31st/12/999. Now select the profiles and then add it here. So select the summer weekday. It is going to be 149. This is the profile number 149, which is for the summer weekday. Weekend it is going to be 150. Select the winter weekday. $151. And winter weekend, 152. So we have assigned all the 4 active profiles. That means they must contain the data. So, I mean, the values should be there in the day profile, and then we can assign it to sensitive profile. Now here we'll enter the dynamic modification factor value profile, and the profile number is 153. 153. Okay, now save it. Now go back to the profile header, change profile number what we created just now, that is for division 60, and profile type, it is synthetic profile. So profile number 154. 156, this is the latest profile what I created. 154 we did not go ahead because it was not having the values for the day profile. So 156, and selection date 01/01/2019 to 31/12/999. Select it and then go to details. Here we have to generate the data. Okay, for generation of data we will start generating for 2019, 2020, 2021. At a time we can create for any number of years. So we will say first we are going to generate the data for 01/01/2019 up to 31/12/999. 31/12/2019, and then generate. So here you have got a icon, generate the profile value. Okay, we are generating the data for first year, generate. Now decimal places have to be truncated. Truncated decimal places is 2 because we have given in the sensitive profile decimal places as 2. Do you want to cancel the generation of the profile value and check the number of decimal places in the header data? Okay, actually it is calculating more than 2 decimal, so it is asking, do you want to truncate it, not generate, go back to header and then change, or do you want to go ahead with that? It is okay for us to have the 2 decimal places, so we will say no. Okay, so no. So profile values are generated successfully, and then save it. Now we will go to 01/01/2020, and then we will say 31/12/2020, and then generate the values. Values created, save it. Likewise, we can create for 21 and 21. And then save it. So now we will see whether the values have been generated for 156. I can go and check in the values data, 156, profile value, and profile is 156 01/01/2019 to 31/12/2019. Select the profile. So you cannot edit. So actually you should not open it in the change mode. It should be in display mode. So right now it is showing in the display mode. I mean, sensitive profile is not available for editing. Basically, we are not entering any data in the sensitive profile. It is rather being generated. Okay, so that's why it is saying you have to see it in the day profile, in the display mode only. So it has generated the data. So for the whole year, we can see the data has been generated for the entire period for the 2019. So that means the values have been generated for all the months put together for the whole year. Okay, it is containing the value. Now, these values are generated based on the sample data, what we have for the day profile. In a way, we are saying, even though we are not having the smart meter, we have put a smart meter actually for a 2-bedroom apartment, and then we have measured the consumption for a typical day in the summer and winter for weekday, weekend. Based on that, we have generated the data. So similarly, we can have the data checked for 2020 up to, let's say, 31st 12 2020. So now values have been generated here also. Okay. So basically generating the value for all the years what we have used. Now when the synthetic profile is generated, simultaneously along with that, in the system it will create one more profile which is called integral profile. The integral profile is actually kept for SAP. It is going to generate a synthetic, based on the synthetic profile, an integral profile. So whether integral profile has been created and what are its value, we have to check it. So let us go to display mode and then go to profile and select the profile, let's say for the division 60, and then profile type integral profile. Select integral profile and then select here. So it has generated a integral profile 157. Okay, this is the actually profile, because 156 is our actual profile. 155 also there because we had one more synthetic profile created initially, but that we ignored. But our actual integral profile is 157, and then we will select one day first to explain the concept of integral profile. So 01/01 2019. We will take it as 01/01 2019. For the first day, it has got the value, and then select it here. So it has got the value in 4 decimal. Okay. Now simultaneously we'll also open 156, which is the actual synthetic profile for the same period. Now here we can see what is the purpose of synthetic profile. Now synthetic profile is having the consumption data for each interval. Okay, this is consumption happened between, from 11:45 to midnight. Okay, and then this is the consumption happened between midnight to 12:15. Okay, now what integral profile will do, it will keep adding the cumulative value. That means here it is actually 0.245, but because of the decimals it is taking 0.2480. Okay, 0.2480, and then it is showing 0.4960. What is this value? This is the value added for the consumption happened between these two periods. Okay, that means for each period it will keep on adding cumulative value up to that point. Okay, that means if you see by end of the day what is the value. Okay, if you see by end of the day what is the value. So if you go to the last value, that is at 11:45, it is showing 35.51. Okay, that means every 15 minutes data it keeps on adding cumulatively as the time will go by. That means from 2019 January, if you take by 31st of December 2019, we would have seen the whole consumption for the whole period. Okay, but for a particular month, okay, let's say in the month of January, starting from 1st of January to 31st of January, what is the consumption? Okay, so if you know the value what we have in the beginning of the month and then 31st, if you deduct them, that is the consumption what is supposed to have happened. If it was a smart meter, what would have been the consumption data? That means here you can see on 23.45 it is 35.51. Okay, that's the consumption cumulative, and starting was 0.2480. Okay, so the consumption for this particular day is coming to 35.5136. Okay, so like this, if you take it for the whole month, what will be the consumption? Okay, so if you select one sample month going from 1st of January to 31st of January 01 2019, and if you select here, so this is for 157, we'll take it for 157, integral profile. So here we can see for the integral profile 157, what is the consumption which is happening end of it. So if you go to 1st of January, 2nd of January, like that, or if you take from 31st, we'll take 31st itself, 31st 01 2019. So if you see by end of the 31st night, okay, if you can see here, what is the consumption? It is coming to 964. It's coming to 966.26. That means for the month of January, when it has added all the cumulative values for the based on the synthetic profile, it's coming to 966.26. So let's say this is the value what we have got for 966.26, which is the consumption value. Now this is based on the integral profile. Now, how the system will use this information, we will see. Now what we'll do, we'll create one regular installation data with the premise and everything, and we will assign the regular meter itself. Okay, that means conventional meter, because if the interval meter is there, then there's no need of any synthetic profile. If interval meter is not there, then only we are assigning the synthetic profile. So here what we'll do, we will go and create one regular installation. Go to technical master data and then installation change. We will find out existing installation 60, so 223. So our premise here is 179. 179 is the premise. So for 179 premise, we'll create one new premise 179 and then save it. It is going to be premise number 221. Premise is 221. Now we'll create one installation ES30 01 2019. Division is 60. Our premise here is 221. And our billing class is Z600, rate category Z600, and MR unit is ES1. Okay. That is the conventional meter what we have got, and then save it. So installation 252 has been created. Installation 252. Now here we will find out a regular device what we have got, and then we'll pick up one device and then do the device installation. So go to MM60 and 6001. So 241 is the device category, 241. So we will go to IQ09. Select the material number as 241. And then we will take the status included as AVLB. So here we got a serial number 1118. That is the serial number available. Copy. We will do the device installation. So go to EZ31. Our installation number is 252. 01 2019, and our new device is 1118. Device location. Meter reading is 0. Let's say periodic consumption expected per day. Okay. So we got here approximately how much consumption. We saw the consumption is 966.26. divided by 30. Okay, average consumption, how much it is coming to? So 966.26. This is for the whole month divided by 30. 31 days we have taken up to 31. So approximately 31 kilowatt hours is coming. Let's say we will take it as 33 or something. So 33 into 31, it's coming to 1023. Let's say 1100 is the expected consumption. 1100 is the consumption for 30 days, 31 days. And the rate type is Z600. So we have given here the estimated meter reading value for 1 month, that is 1100 kilowatt hours. Okay. Now this will be the rate type based on which rate will be decided, and then save it. Now for this particular installation, we will now do a move-in. A contract should be created. So go to EC50E. Move-in date is going to be 01. You can take any number of days. It can be 1st of January or even 1st of 2020. But why I'm taking 1st of January? I mean, just to show you how the integral profile value is taken into consideration. The logic is same. Any particular date you do move in, or for any month you are doing the meter reading. Okay. So for understanding, I'm doing it as 01/01/2019, and the contract account we will take it as 1503. Just let me find out. So 6000 is the company code group, and it is 5301. Okay, and then our installation here is 252. Initial metering data is 0 only, because the date of moving and date of installation activation is also first only. That's the reason it is straight away taking the meter reading what you entered as 0 at the time of device installation. Now we will save it. So here a contract has been created as 253. Okay. Now we will do our regular meter reading for the month of January. So go to EL01, and then installation is going to be 252, and the meter reading region is going to be 01, and then execute. So we are doing the meter reading for the month of January 2019. So select 30/01/2019 and then create the order. Then we will enter the meter reading results, EL28, installation 252. The expected estimated value is 1064. Let us say we'll make it as 1100, and then save it. This is a meter reading for this particular month. Now save it. So meter readings have been updated. Now if you go to our particular installation, what we have got, 252, and then if you go to billing periods and the MR result, it is coming to 1000. For the period starting from 01 to 30/01, it is coming to 1100. Now we'll go to load profile and then create the assignment. Valid from 01/01/2019 up to 31st/12/99. Now the load profile. What is the load profile? The sensitivity profile what you created. The sensitivity profile what you created is 156, and then enter. Enter a load profile with the varied usage factor. The usage factor, actually system will calculate every month when you upload the meter reading result, but here, since we have got the data entered manually, and also first month, we have to calculate the usage factor. So select the usage factor and then calculate. So valid from 01/01/2019 till 30th of 01 2019. Now profile number 156 and then quantity consumed. Okay, let's say continue. Profile factor. So quantity consumed, this is valid up to 30th of 01 2019. Our quantity consumed is coming to 1000. Okay, 1100. It's coming to 1100, and then calculate the factor. So now what it is doing, it is checking the integral profile, and from the integral profile it is finding what is the cumulative data till 30th of January. Okay, that means starting from 1st of January to 2019, what is the cumulative value? So according to synthetic profile, it is coming to 937, but actual consumption value is coming to 1100. So it is calculating a usage factor as 1.1738. Continue and then continue. So here entered manually, actually entered manually, calculated automatically, extrapolated, calculated after manual change. Okay, so automatic calculation also will happen, but there's some control. How it happens, I have to check it, but it can happen automatically once you enter the metering result every month. Calculate automatically means here we have done manual, but every month when you enter the metering result, it'll keep on calculating for each month. Now, what is the purpose of this particular profile value? What is the purpose of this usage factor? Now you see, let us say there are two installations. Okay, one installation is 252, another installation is 253, another installation is 254. Okay, for all of them we have assigned the same synthetic profile 156, 156, 156, because these are all basically the this is a synthetic profile for a typical 2-bedroom apartment. Okay, naturally the synthetic profiles are not created for one installation. They are basically like a kind of a sample profile for a typical 2-bedroom apartment, so it can be assigned to n number of installations. Now according to the integral profile, that is based on the synthetic profile, our consumption is coming to 963 according to integral profile. This is 963, this is 963. Now, once you do the regular meter reading from the conventional meter, you are entering the results. So here you entered 1100. Let's say for this, the meter reading was 950, and maybe for this it was 1300, let us assume. In both the cases, in all these cases, it will calculate the multiplication factor. So here is calculating as 1.17. Here it is less actually, so it may be 0.956, 0.96. Okay, or here it may be more actually, so it may be 1.34 or 1.4. Okay, 42. That means for each of the installation, it will calculate the multiplication factor. Then, when the distribution companies are sending the data to the generating company, what it will do, it will take the synthetic profile, actual value of the synthetic profile, multiply all those values with the multiplication factor. That means for this particular installation, that is 252, the original synthetic profile values are available in 156. Multiply each of the value with 1.17, then you get the broken down consumption data for synthetic, broken down consumption for 252 installation. Even though you are not having the smart meter, because you are using a integral profile, the synthetic profile, those values are multiplied with the data what is coming from the actual meter. So we are breaking down that consumption of 1100 into interval data for the whole month. That means every 50 minutes data, but it is expected to vary for each installation, because some installations will consume more, some will consume less, but each of them has got the same synthetic profile. So for all of them, it will multiply the value with the multiplication factor of that installation, and the revised profile will be generated. Then it will add up all these values and then come to know what is the interval consumption data for the day, first day, second day, third day, or for the whole period, and send this data to the generating company for the purpose of settlement, or based on this data, the generating company can plan for the, the generation profile or generation to be done for the coming month. Okay, so synthetic profiles are not used for billing. Billings are based on the actual meter. That is a conventional meter what we have got. Even though you don't have the smart meter, because of the load profile what we have assigned, the system will be able to synthetically generate the data for the actual consumption for the meter based on the reference value what we have in the synthetic profile. And these values will be generated for each and every installation. Then while sending the data, it will add up the data and then create one master consumption profile for the whole month, okay, or day wise, interval wise, and then send this data to the generating company. So the whole exercise of synthetic profile is for the simulation of data where you don't have the actual smart meter, but using the conventional meter, we are able to still visualize what is the interval data. And more or less, this data will be very near to smart meter, because these are all based on the actual consumptions of a smart meter. Although the whole idea is not to see the actual consumption interval data, which is not possible, but very near to that, the values will be available, and it will be helpful to the distribution company to derive the interval data on any given day or for the month and send it to the generating company. So this is a basic exercise for the synthetic profile. So we have seen elementary profile, we have seen the synthetic profile and day profile. Tomorrow we will see how the formula profiles will work. Although we have used formula profile based on copy 01, where the formula profiles were created by the system when the RTP ran, but how it actually created those profiles, that we want to see. So we will do the profile, basically formula profile, with two types of formula. One is copy 01 and there is a limit 02. Now limit 02 is also a very widely used concept of formula profile, which can be used in the RTP. Whatever RTP you have designed, that was based on peak, off peak, mid peak, and the demand value. But if you use limit 02, you will be building two values. The consumptions happened up to or below the limit, one amount, and consumption happened above the limit. So it is also called spot pricing. It's called spot pricing. That means the company will fix some limit data. As long as you're consuming up to that point or below that point, your value is going to be 1. And for consumptions which you are done above the limit, you'll have to pay some additional amount. The system will use the limit 02 concept. So here we are checking straight away on the profile part, but you can also integrate in the integral profile. So I'll give you some hints when you are practicing the RTP. See whether you can generate an RTP for that. I'll give you all the hints. You can take it as a kind of a project, and then when you're working, you can check whether you can work actually on a RTP based on the limit 02. Okay. So tomorrow we'll continue with the formula profile. Is it okay?